Okay, picking back up on 45, I kind of ran out of space on that last video, but here's where I checked it in my calculator. You can do that, and that gives you a good way of checking your answer. You want those values to come out to be exactly the same. Okay, picking up on number 46. On number 46, they are asking me to find the exact value of this thing, and what they've done is they've already given it to you in the formula format. So the sine of 42 and the cosine of 12. And then we're subtracting the sine of 12 and the cosine of 42. So we're working in degrees here. And by starting with sine, they're telling you that you're using the sine formula. And with sine, when you have a minus on the inside, you have a minus over here at the beginning as well. So I'm going to go ahead and put my minus. And then my alpha, or my x angle, is 42. And my beta, or my x angle there, or y angle there, is 12. And so they repeat over here, 12 and 42. I think I got mine out of order, but there we go, 42 and 12. Oh, they've got them written backwards. Anyways, doesn't matter. Either way that they have them written, that's what we're working with here. All right, so let me go ahead and say then that what we're finding is the sine of 30 degrees. 42 minus 12 will give me 30 degrees. And 30 degrees I know is the same thing as pi over 6. So again, if you're more comfortable working in radians, that's perfectly fine. So in the unit circle, the sine of pi over 6 is 1/2. All right, on 47, we're doing the same thing. This time we're working with cosine, however. So we've got pi over 16 and the cosine of 3 pi over 16. And then we're going to subtract both of those with sine. Okay, so since this one starts off cosine, I know I'm working with a cosine formula. I next need to decide if I'm working sum or difference. So with cosine, when we have a minus over here, we have a plus over here. So this was a sum formula to start off with. And I'm going to put in pi over 16 and 3 pi over 16. Those are my two angles. So really what we're finding here is the cosine of 4 pi over 16, or the cosine of pi over 4. And again, on my unit circle, I know the cosine of pi over 4 is the square root of 2 over 2. All right, on 48, we work a triangle problem using a double angle formula. So you'll need to know the double angle formulas on the test. And so on this one, they've given me a couple of pieces of information. But first, they've told me to draw my triangle between 3 pi over 2 and 2 pi. So 3 pi over 2 is right here, 2 pi is right here. So I'm going to draw x on x and y not on y, and put theta at the origin. Now they've given me a cosine value, which is 5 over 13, so that's going to be my adjacent side over my hypotenuse. And then I know that x is positive here. I know the hypotenuse is always positive, but I know this y value right here, since it's going down, is going to be a negative, and this is a 5, 12, 13 triangle. So you may want to go back and look over all of your Pythagorean triples. All right, first it asked me to find the double angle for sine. So my formula for the double angle for sine is 2 sine cosine. If you need to go back and look over how to develop those, you can. And so from this triangle, my sine value is going to be negative 12 over 13. And my cosine value was given to me as 5 over 13. And so now I can multiply top times top times top, and bottom times bottom times bottom. So top times top times top gives me negative 120, and 1 times 13 just gives me 169. Okay, for my double angle for cosine, I'm going to work with my formula cosine squared theta minus sine squared theta. Again, one that you need to know for the test. So cosine is going to be 5 over 13 squared, and I'm going to subtract from that negative 12 over 13 squared. And be careful when squaring that negative right there. So this is going to give me 25 over 169 minus, and that's going to become a positive, 144 over 169. So 25 minus 144, we already have a common denominator, gives me negative 119 over 169. And then finally on this same question, they asked me to find the double angle for tangent. So that formula is 2 tangent theta over 1 minus tangent squared. Again, another formula you need to know for the test. So on the top, I'm going to have tangent, which is negative 12 over 5. And on the bottom, I'm going to have 1 minus negative 12 over 5 squared. Alright, so on the top I'm going to multiply, again, top times top, and bottom times bottom. That's going to give me negative 24 over 5. And on the bottom, I'm going to go ahead and square this first. That gives me 144 over 25, because now I can make this a common denominator of 25 over 25. So I'm just going to change my 1 right there. So let's go ahead and keep my negative 24 over 5 on that one. And then on the bottom, I've got 25 minus 144 again. That gives me negative 119 again over 25. And now one of our things that we do a lot in pre-cal, I'm going to use multiply by the reciprocal, or keep it, change it, and flip it. And I'm going to go ahead and let my 5 and my 25 cancel out. And a negative over a negative becomes a positive, and so that's going to give me 120. I think, I'm going to make sure. Yep, 120 over 119. So don't forget to go back and look over your double angle formulas. And then our last question about this topic, number 49, we're working with a half angle formula, and we're working with sine. So let me start by writing this down. I've got the sine of 105 degrees. So I want to know 1/2 times what would give me 105. So I'm going to double that, and that's going to give me 210. And 210 is the same angle as 7 pi over 6, again, if you're more comfortable working in radians. All right, so my sine formula for a half angle, and we're going to give you this formula on the test, is plus or minus the square root of 1 minus the cosine of theta divided by 2. Now, I'm going to use my original angle here to pick the plus or minus. So I know 105 is in the second quadrant right here, where sine is positive. So I'm going to work with the positive version of this formula. And then everything else I'm going to do, I'm going to work with my 7 pi over 6 and divide by 2. All right, now 7 pi over 6, move down here, is in the third quadrant, where I know that cosine is negative, and I know my cosine value there is the square root of 3 over 2. Still got that denominator of 2 down there. All right, let's change that minus a negative into a plus. I'm going to go ahead and change my 1 into 2 over 2. So that's going to give me 2 plus the square root of 3 over 2 over 2. And again, let's use our keep it, change it, and when I flip this, I get 1/2. And I can separate that square root into a top and into the bottom. And so that's going to give me the square root of 2 plus the square root of 3. It's okay to have a square root inside a square root. And then I'm going to divide by 2 down there on the bottom. And again, I can check this on my calculator. Let's work in degree mode for this one. And I'm going to put in the sine of 105. And then I'm going to do alpha F1 number 1 and put in the square root of 2 plus the square root of 3, all divided by 2. And we should come out with the same answer, and we do.